Good morning, everyone. Welcome to our fourth and final day of press conferences at the EGU2014 General Assembly. And our first media briefing today is on applying geosciences to crops, coffee, forensics, and wine. And I'd like to remind everyone here that we'll open the floor for questions following short presentations from the panelists. And the journalists here are welcome to ask questions, and those watching remotely can ask questions by adding EGU.media to their Skype contacts or by using the hashtag AskEGU on Twitter. So I'll just introduce our panelists now. We have Jim Hellinger, who is a director at the Stable Isotope Ratio Facility for Environmental Research at the University of Utah in Salt Lake City in the US. Urtzi Laibar, who is a researcher at the Environment Quality Department at Necar Tecnalia in Derio in Spain. We have Risi Karapanagiotti, who is an assistant professor at the Department of Chemistry at the University of Patras in Greece. And Stefan Fritz, who is a group leader at the Earth Observation Systems, Ecosystem Services and Management at the International Institute for Applied System Analysis here in Vienna. I'll now hand over to our speakers. Thank you.
Thank you. My name is Jim Ellringer, and I'm going to tell you today about a talk which is an application, and it's an application of natural recorders, that is the stable isotopes in your hair, which are recording both your travels and your diet. And there are 4 take-home points. The first is that we have produced and now verified a stable isotope model that says something about the region of origin and the travel histories of humans, and applying this to previously unidentified murder victims to assist law enforcement. We use scalp hair as a linear recorder of an individual's travel. And that is because the hydrogen, carbon, oxygen, nitrogen, oxygen, and sulfur in your hair is produced only at the time when the hair in the hair follicle, and once it is extruded onto the surface, there's no change. So we have a linear recorder, and we're going to use this to assist law enforcement in identifying previously unidentified murder victims. We can use carbon and nitrogen, oxygen. Carbon and sulfur isotopes to say something about food sources. Oxygen tells us something about drinking water. We base our approach on a very common geological technique of knowing that there's variation in the isotope ratios of water across the continents. We then link this with a mathematical model. We use the term isoscape to describe the maps that I'll show you. Okay. Now, the application is going to be assisting law enforcement, as I said, and I'm going to show you the first 4 cases in which we've applied this. So we've now had enough time to develop and test the model and actually apply it and see some results. The first case I'll tell you about is a case of a murder victim. She was known as Saltaire Sally. This is a facial reconstruction. They found hair, bones, and the necklace at the scene. They asked us, was she a resident? If so, good. If not, had she been a visitor or was she traveled? What you see in the graphic here is a line with the most recent time on the far right and most distant time in the far left, and you see a line that squiggles up and down. I don't have a pointer, but the very last point on the far right is an indication of the value that you'd expect if she was from Salt Lake City. So our first comment to the law enforcement was she is a resident, but she has traveled. She has traveled a lot. Where had she traveled? So we used our model to predict where she had traveled and defined 4 regions. Region 1 is the Salt Lake Valley. So she was, the model predicts that colored area with the blue dot indicating Salt Lake Valley. So we don't identify a zip code, but we identify a region. Among the regions that we identified which helped law enforcement was that approximately a year before her death, she visited an area which is consistent with Portland, Seattle, in the Northwest. In fact, she had visited her mother a year before her death, and it was by identifying Portland and Washington and Seattle as places that they were able to make the link. The second victim I'll tell you about is a previously unidentified victim now known as Patricia Barrett. 6 months before her death, the isotopes say she was a resident of Salt Lake City. They couldn't identify her as a resident in Salt Lake City because it turned out that she was a wanderer, a schizophrenic wanderer. 6 months before that, the isotopes predicted a very definite location in central Texas. When they began to look for missing people that might have come from Dallas, Texas, they identified her as the candidate, and both of these were verified by genetics. She was an extreme wanderer, and if we look at the period 12 to 18 months before her death, we see another part of the southwestern United States. She had come back before her death, the 6 months before she died, and said she had been in the southeastern U.S. looking for where she had been born. So the hair suggested that she had been traveling through the southeastern U.S., and the yellow circled area is the area where she is thought to have been born. So in both of these cases, and in fact all four of them that I'll talk about tomorrow, the isotopes correctly predict where a person had been and their travels. This is being applied now on a routine basis for law enforcement in the United States.
Good morning, my name is Urtzileibar. We have studied the effect of a complex phenomenon as the climate change. I would like to briefly present what we have done. A greenhouse experiment was carried out last year with potted, unrooted fruit-bearing cuttings of vine, cultivar tempranillo. We simulated these specific conditions for Spain that are set by the Intergovernmental Panel on Climate Change. These conditions were an increase on carbon dioxide concentration to up to 700 ppm, an increase on the temperature of 4 degrees Celsius, and a decrease in the relative humidity. The Tempranillo variety was used as it is the most internationally Spanish variety recognized. And it should be noted that these experiment conditions cannot be extrapolated to other locations as these are specific to the place where the experiment was carried out. In other places, other climate conditions are expected, so So the climate will cause different effects. We have studied three factors. The first one was the climate change, the second was the soil texture, and the third, the water stress. Among the most important results obtained in terms of yield and quality parameters, it was observed that the climate change shortened the time between fruit set and the harvest date up to 9 days, which is determined by the degree of sugar that turns to alcohol after in the fermentation. In the greenhouse with the climate change conditions, the plants berries produce a higher pH, which is due to the higher temperature, elevated carbon dioxide, and lower relative humidity. A higher pH is something not desirable because winemakers want a low pH to preserve better the wines. Acids are degraded at high temperatures, decreasing the acidity and increasing the pH. In addition, berries grown under climate change conditions produce masts with lower anthocyanin content and therefore a lower color intensity than plants grown under current conditions. This is something also that it's not good for the wines. Taking into account the second factor, the soil texture, sandy soils increase root fresh weight in comparison with clayey soils. This could be due to the fact that roots have a greater penetrability in sandy soils than in clayey soils. Clayey soils have a higher porosity than sandy soils, and clayey soils have many micropores, while the sandy ones have few macropores where the roots could enter more easily. Besides the difference in the roots, we have only seen in terms of quality differences in anthocyanin concentration, being the higher anthocyanin concentration in sandy soils. For the third factor, the water stress, delayed harvest date up to 10 days. These plants under the water deficit conditions had less vegetative growth due to the stress they have suffered. And moreover, these plants produce lower root weight in comparison with well-irrigated plants. Moreover, berries grown under water deficit conditions had a higher skin pulp ratio. And these berries produce masts with higher pH and lower polyphenol content. Again, this indicates a lower quality of the wines. So in conclusion, climate change shortened the harvest date, increasing pH and reducing anthocyanin concentration. Moreover, water deficit delayed harvest date, reducing vegetative growth, increasing again pH and reducing polyphenol content. Meanwhile, soil texture affected root configuration and the anthocyanin concentration. So therefore, effects of climate change and water availability on different soil conditions should be considered to mitigate the potential damage from future climate conditions or to take full advantage of the opportunities associated. Thank you very much.
Good morning from me as well. The work I'm going to present today is performed by my PhD student, Ms. Fotopoulou, from the Department of Chemistry, and in collaboration with my colleague, Professor Ioannis Manariotis, from the Department of Civil Engineering. We are all located in the University of Patras in Greece. What we found in this research is that we can use coffee residue collected from a coffee shop and turn it into a material that can be used to treat water, purify water, and remediate contaminated soils and sediments. This coffee residue, given the correct conditions under pyrolysis, can result in a material that has a very high surface area and can be used as a sorbent. The good about these coffee residues is that they are easy to collect. Actually, a coffee operator in a coffee machine can produce really pure raw material. For example, our sample came from the university coffee shop. And this coffee residue is not used as, for example, food, or is not used as a feedstock. So we are not competing with food sources, and this is in compliance with the European Union that doesn't like materials that are competing with food. So we found this as an interesting idea to use this coffee residue to create a new material. What we do is we use pyrolysis to produce high porous materials, and thus they have the high surface area. The truth is we have used this technique with other agro-industrial products such as malt spent rootlets, grape seeds, olive seeds, but coffee residue gave us the highest surface area so far. So we found this as a promising material. We have used these materials from other raw materials to sorb mercury and to sorb phenanthrene. Mercury is a toxic heavy metal. Phenanthrene is a nasty polyaromatic hydrocarbon. So we don't want these compounds to be in the drinking water. So far, the treated coffee residue gave us very good results, and the sorption capacity, their ability to remove these pollutants from water was really high compared to the raw material. So we are very pleased with the results, and we think that we can find an application even better than what we are showing here if we look in other applications as well. So far we have tested what we usually test in our laboratory, but we are optimistic that we can find a better application. Our ultimate goal is to have a sustainable use for this sorbent. That is to, for example, in a coffee shop, the operator collects this coffee residue and use optimum facility, a small oven, for example, with a low cost to produce this sorbent, even in the coffee shop. And then use this sorbent, this new material with a high surface area, to remove taste or odor from water and get a very pure water, and use this to create a very tasty coffee for the customers. So that's the idea of our work. Thank you.
Good morning, everybody. My name is Steffen Fritz. I'm from the International Institute for Applied Systems Analysis, which is just outside Vienna. And I'll tell you a little bit about a game we have developed to collect very important data for science. Basically, if you look into the current developments of serious gaming, it is really on the rise. So there are more and more games found with a purpose, not just for entertainment. And if you really add up all the numbers of hours people are playing around the world, you come up to 3 billion hours of playtime a week, which people, gamers, are playing in 1 week. And that is really amazing. So if we could use all that time for a scientific purpose or for other purposes, this would be really good, and it could help the world in some ways. So if you look into the developments of serious gaming, there are games for health. Education has a long history of serious gaming where people say, you know, I'm playing this game and I learned more than reading 10 newspapers, for example. But also now, more recently, we start to use gaming for science. And we made it actually in the top 10 games of the Observer when they reported about this phenomena. And the game, besides here also presented Folded, which is and was very successful, is called our game Cropland Capture. Basically, why did we develop it is because currently if you look into cropland on a global level and the extent current maps represent it, the uncertainty is very high. We don't really know in the developing countries where exactly cropland is located. There are some statistics, but the spatial distribution in some countries is really has quite high uncertainties. So we thought, why not use Google Earth and imagery which everybody can look at, and also other imagery we can get hold of, as well as pictures which are available to everybody, which are geolocated. We know we have access to so many pictures people have taken at different locations, and we can maybe ask people to help us to tell us if at these locations they can see some cropland or not. And we can then use this data and integrate it into new and better maps. We can use it for training satellite algorithms which classify satellite images. And this game we developed is really for everybody. It's for you and me, for people who are interested in general, also in helping science and maybe winning prizes. It's very simple. It's available cross-platform, also on mobile devices, available on your iPhone. You can download it on your Android phone, but also as a desktop application. And it basically just asks you, do you see cropland in this red box? Yes or no? And you get immediately an answer. You get immediately feedback back if you were right or not. But also, if you say there is cropland and the computer tells you you were wrong, but you disagree with the answer given, you can contest it and you can say, I don't agree. So how does this really work? We basically use frequency distributions. We put several players on the same points, and when somebody is good, we let him into new territory and we risk and tell him he was right, but he doesn't know when he's in new territory. What is the motivation to get people for this? It's basically first to help science, but also to have fun. And you can win prizes with this. We have a leaderboard where you can see how many squares you have classified correctly, and you can compare yourself with other players. We have weekly prizes, and we have 3 final winners. Currently, around 4,000 people are playing this game, and we have had more than 4 million of those squares you've seen classified. We've put people on the same spots many times to increase confidence on those points. So this is something very practical. You can all try it out. And if you report about this game, please put the website, because this would help us. We can potentially get more players. This game is still going on for 1 more week. It has been going on for half a year so far, and we are really happy to have so many players engaged and so many points collected, but there is much more to do. So far, if you add up the area we've collected, it adds up to roughly the size of India, but what we really want to do is we want to map the world at some point. Thank you very much.
Thank you very much. We'll now open the floor for questions. Are there any questions?
Rosalie, working for EGU. It's a question for Jim. You mentioned carbon and sulfur isotopes can be used to say something about the victims' food choices. I just wondered how much resolution you could hope to have here about their diet. Do they like a particular food? Are they vegetarian? Or?
So we use this first as a way of determining whether or not an unidentified victim has come from Europe or North America. Mm-hmm. And the reliability is greater than 99%. That we can distinguish you on the basis of a sulfur isotope and a carbon isotope. This has simply to do with the food choices that we have. We might all eat hamburger, but our hamburger is produced from a C3 plant or from a C4 plant, depending on the continent, for example.
Thank you. Are there any other questions?
This question is for Hirsi.
Yeah.
And I was wondering if you have tried, or if you're planning on doing tests with arsenic as well. And I'm Christina Reed with Climate Wire.
Okay, thank you. Yes, in our immediate plan is to try different metals. So far, mercury is a heavy metal, but in water it stays as a molecule together with chloride. So our goal is to try new metals, such as arsenic, that has a different form in water, and see if it works with such metals as well. Definitely. Thank you.
Hi, Akbar Hussain from the University of Leeds. Again for Jim, your new geochemical techniques, are they going to be applied further afield other than the United States?
So we have attempted to engage our European colleagues, and I know of at least 1 or 2 colleagues that are doing roughly the same kinds of analyses. Yes. We do not have good maps yet for hair across Europe, although we have good, we think good tap water models. So I'd say we're in a beta phase.
And There was some talk, Jim, last year, I believe, the UK had said something about testing to determine immigration laws. Has this come up in your work? Has there been any sort of interest or pushback in terms of where this could possibly go or lead to?
I am aware that there was an effort, maybe by the London police, to do something at the airports. And I think my comment and the comment of everyone else is that it was very premature. That technique was not based on looking at hair, but the idea was to look at body water, which is the foundation. And the challenge is that it's very easy to change body water, and the models do not yet take into consideration some of the factors that are required before this can be applied in that way.
Hi, Liz Callagher from Environmental Research Hub with a question for Stefan. Can you tell us who do you think is playing these games? Do you have data on that?
We haven't yet fully analyzed all the data on where the players are coming from, but I can tell you that a lot of players are actually from the US, and the reason is that we made it to this website on an NPR website, the SALT, which everybody knows in the US, all academics know it, and that day when it was on that website, we got 1,800 more registered users that day. So I would roughly say at least 50% of the players are from North America, potentially US, and then the rest I would estimate is distributed quite equally. There will also be some from India. We have some players from India. There won't be many, I think, from Africa due to internet access limitations, for example.
Thank you.
Are there any other questions? Okay, if there aren't, you are welcome to approach our panelists, and we'll finish here, and the next press conference is on the fingerprints of life at 11 o'clock. Thank you. Thank you for the fascinating presentations, all four of you. Thank you.